Hi, geometry students. Let's look at lesson 6, unit 1, and work on some proofs. So we're going to prove an idea about lines and angles, and our essential question isn't too far removed from that. How can I prove an idea about lines and angles? You'll probably need to pause the video as I won't be writing out as many words this time. There's two types of angle pairs. There's adjacent angles and a special type of an adjacent angle called a linear pair. So adjacent angles are two angles in the same plane with a common vertex. So they both have a common vertex and they both share a common side. So I'm going to create then adjacent angles, which are just two angles that are touching each other. So they share a vertex, they share an elbow, and they share a common side. So if I label these angle 1 and angle 2, we can say angle 1 and angle 2 are adjacent angles. A special form of adjacent angles is called a linear pair. So a linear pair just means two adjacent angles. So we must have a common vertex and we must have a common side. Okay, so we have a pair of adjacent angles. So everything that is true for adjacent angles has to be true for a linear pair whose non-common side forms a line. And we can say that angle 3 and angle 4 form a linear pair. We've got some examples. Identify angle pairs. So our verb is identify. We're identifying angle pairs and we're identifying them as adjacent or touching, not adjacent, not touching, or that special form of adjacent angles, linear. So if we first look at angle 1 and angle 2, we see that they do share a common vertex and a common side, and so we can label those adjacent. If we look at angle 2 and angle 4, I can see that angle 2 and angle 4 do share a common side. However, they do not share a common vertex, so they cannot be adjacent. This one was tricky. I'll clean this up. All right, so then let's see, we have angle 1 and angle 3. Ooh, I see that they're making a line. So these are going to be linear. They have a linear pair. All right, here we see three angles. Angle A is measured 53 degrees, angle B 37, and angle C 127 degrees. So when we have two angles that add up to give us 90 degrees, we call those angles complementary angles. So complementary angles are two angles, only two, whose measure have a sum of 90 degrees. So if we look at angle A, we have 53 degrees, and angle B, here's 37 degrees. They do add up to 90. When we have two angles who add up to 180 degrees, we call that supplementary angles. So two angles again, not three or not one. So we have two angles whose measure add together to give us 180 degrees. So angle A was 53 degrees plus angle C was 127 degrees. That does add up to 180. Okay. This one is kind of tricky, example 2. So find the measures of complements. So a complement is an angle, one of the angles added to be complementary angles. So first thing we got to do is we have an error. So we want to find the complement of angle M. So when we have angle M, what we're asking is to find this angle that would give us the sum of 90 degrees. So really all we have to do is to take 90 degrees and subtract what we know. We know measure of angle M is 26.8, and if we subtract that out, we get 63.2 degrees. So the measure of angle X is 63.2 degrees. We can do that with some algebra. So to find the supplement of angle N, we see that angle N is an expression 2y plus 20. So knowing that supplementary angles are two angles that equal 180, start with 180 and subtract what we have. So we're going to subtract the quantity of 2y plus 20. If we distribute the negative, we have negative 1 times 2y, which gives us negative 2y, and negative 1 times 20 gives me negative 20. And if I bring down the 180, what I see is, well, the only thing I can do is add together my constants. So 180 subtract 20 gives me 160, and I'm just going to subtract 2y. So that's the measure of my complement. So this is the measure of this teeny tiny angle here, 160 minus 2y quantity degrees. Well, that's that missing angle to give us 180. Okay, here I see an interesting picture. Here I see I have vertical angles. So vertical angles are two non-adjacent angles formed by two intersecting lines. So in my figure, I have one line intersected by another, and I can look at angle 1. If I find that first, I can look for my vertical angles. So I'm going to look across the intersection. Okay, they've got to be not adjacent, so this means not touching. We have another pair, so we can say that angle 2 and angle 4 are vertical angles. Great. Let's practice. So example 3, name the vertical angles in the picture. So we're just going to start with one angle. Let's start with angle EDF. Is vertical angles, I'm going to go across the intersection to angle GDH. I've got two angles left. Let's see if they're vertical. Let's start with angle EDG. And if I go across the intersection, I get vertical angle of FDH. And since these are probably different measures, I'll do two lines. Great. All right, let's do our first proof. Exciting. So we're going to reason logically from given facts. Here's our given facts, and we're going to reach a conclusion. So the conclusion that we're going to reach is to prove that angle 1 is congruent to angle 4. But we have to start our proofs with our given information because that's all we know are our given information. And when we're talking about given facts, we're talking about definitions and our rules. When we're filling in our proofs, we have, this is called we can put it in a table, 2-column proof. And on the left, we have our statements. Statements are things that we notice. Statements are things that are true. And when we list things that we notice and things that are true on the left, what we have to think about is our reason why. So every time you write a statement on the left, think of a younger brother and sister. younger cousin or somebody that you babysit that's in that why stage, and just always endlessly asking why. So when we have the statement angle 1 and angle 4 are vertical angles, well, how do we know that, or why do we know that? And the reason is that it's given. From here, it's not a lot to go on. I could define vertical angles, but I'm going to start with something that I notice. I notice that angle 1 and angle 5, angle 1 and angle 5, look at this, they're a linear pair. Together they're adjacent and they form a line. Okay? And why can I say that? Well, I'm using the definition. So this symbol equals df means a definition, definition for linear pair. And the definition is if a pair of adjacent angles whose non-common side form a straight line, then the pair are linear. Right? There's something else I notice. I notice that angle 1 and angle 5 also add up to 180 degrees. So we can say that they're supplementary. So angle 1 and angle 5 are supplementary angles. Oops, needs to go here. And what we're doing, how do I know that? Well, if angles form a linear pair, then the angles are supplementary. So I'm using the definition of supplementary angles. You might see another pattern, but I'll talk about it in just a second. So when I know that I've got supplementary angles, well, then I know they add to 180 degrees. So the measure of angle 1 plus the measure of angle 5 make a half of a circle. And if a full circle is 360 degrees, half of that is 180. So how do I know that? If two angles are supplementary, then they add to 180 degrees. And also angle 4 and angle 5 are also making supplementary angles. From here, we're going to switch gears and do some algebra. And so the measure of angle 1 plus the measure of angle 5 equals, so we have the measure of angle 1 plus the measure of angle 5 equals, I'm not going to say 180, I'm going to do some substitution because I know that the measure of angle 5 plus the measure of angle 4 also equals 180. So it's like I'm taking the measure of angle 5 plus the measure of angle 4 and substituting it in for 180 degrees. I can continue with my algebra and I can subtract measure of angle 5 from both sides. It's a little goofy, but the algebra holds true. They do add to 0, so they cancel to 0, leaving me just with, we'll see it in a second, the measure of angle 1 plus the measure of angle 4 is all that's left, which is really close to what we're trying to prove. But the measure is just something we measure with a protractor, and we can get a number in degrees, but that's the same as the shape. So we can say the measure of angle 1 over here, the measure of angle 1 is equal to the measure of angle 4, then angle 1 is congruent, or the shape is the same as the angle 4. All right, we've got our first proof in, so we will see you next class.